Hey guys, tonight we refloating into something that has quietly baffled some of the most brilliant minds for over a century. Why the universe has a speed limit and why nothing, not even our wildest dreams or the fastest rocket, can outrun light. Imagine you're drifting just above the Earth, tucked inside a soft capsule of silence. You look out, and there's the sky dark, vast, and peppered with distant stars. Each one is shining at you across millions, even billions of years. You're not just seeing points of light, you're seeing ancient messages, whispered across an unfathomable void. But here's the strange part, no matter how long they've been traveling, these beams of light, all of them move at the exact same pace. They never rush, never slow, just a constant, quiet sprint. 299,792,458 meters per second. That's the speed of light, the universe's very own speed limit. And here's your gentle, slightly mind-bending reminder. Even if you tried, if you built a ship that rode on the edge of possibility, this is one rule you could never break. Light speed is the ultimate boundary, and you probably won't survive long enough to reach even a fraction of it. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And let me know in the comments where you're watching from, and what time it is where you are. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You float now, slow and untethered, among the stars. There's no hurry. Far below, the Earth spins without sound. Above you, the sky has no top and no bottom. You reaches here present, and starlight is pouring gently onto your skin like a warm drizzle you can quite feel. The light seems soft and passive, but if you could ask it how fast it's moving, the answer would be strangely specific. Light always knows how fast it's going, and it never changes its mind, even when nothing is watching. This is the first quiet clue in our mystery. Why would something so universal have a speed at all? Why this speed, and not a little faster or slower? It helps to realize that speed, as you know it, is always measured in relation to something else. A car going 60 miles per hour is only going that fast compared to the road. If you were in another car, going right beside it, it might seem to be standing still. But light doesn't care who's watching. Whether you're sitting still or zooming toward it at near light speed, it still greets you at the exact same velocity. You never get to catch up, and it never pulls ahead. That's not just weird, that's unthinkable. Unless the very nature of space and time is stranger than we believe, you start to wonder, maybe it's not the light that's acting odd. Maybe it's our idea of space and time that's in need of a lullaby. And so, the stars continue sending their glow, calmly and consistently, like ancient lighthouses that know their job is just to shine, not to explain. You reach out with your mind, imagining a single beam of light leaving a distant galaxy. It has no feet, no wings, no propeller, it's just moving, always at the same exact pace, unaffected by time, untouched by mass, and immune to any push or pull that you or anyone could invent. What if light isn't just fast? What if it's the definition of fast? Maybe, in some subtle, cosmic way, light's speed is more than a number. Maybe it's a limit built into the rules of the universe itself. Like the edge of a dream you can't go past no matter how far you float. Scientists didn't always know this. For centuries they argued about whether light was infinite in speed or merely extremely fast. It wasn't until the 17th century that Danish astronomer, while observing Jupiter's moons, noticed tiny dilation shifts in timing that hinted light had a finite speed, that it took time to travel. Not much, but enough to measure, if you were patient, and even then no one guessed that this speed would someday turn out to be the very keystone of modern physics. You breathe in, slowly, letting that idea settle into your limbs. The speed of light isn't just a limit for light, it's a limit for everything. It's a number that whispers to the universe, this far, no farther. Even if you gave a spaceship infinite fuel, even if you had a magic engine that never overheated, even if you flew for 1 billion years, you could never quite catch a photon. Not because you're slow, but because the photon doesn't exist in the same way you do. We'll talk more about that later. But for now, know this. Light moves not because it's trying to get anywhere, but because it has no other choice. It cannot rest, it cannot pause, it has no clock inside it, no heartbeat, and because of that it becomes timeless. It's strange to imagine a particle that never ages, that never has a before or after, just a constant now. You're still floating now, gently orbiting the idea of motion itself, wondering if maybe the universe isn't a place of racing and chasing, but of limits and balance, where even something as fast as light is bound by a quiet rulebook older than the stars. And in this stillness, you start to see, speed isn't always about motion. Sometimes, it's about structure. The fabric of space-time has its own pace. It's light. You're still drifting, weightless and calm, your body fading gently into the velvet dark around you. Space feels endless, but not empty. There's a texture to it, like the silence between heartbeats or the hush that follows snowfall. The stars shimmer on, each one sending out its own stream of photons, light particles racing away from their origin, all at the exact same unchangeable pace. And now, you begin to ask yourself the question that anchors this whole dreamlike journey. Why that speed? Why 299,792,458 meters per second? Why not twice that? Or half? Why anything at all? It's such a strange thing to think about. Most speeds, are arbitrarily decided by human limits, machines, terrain, the speed of your walk, a car on a highway, even a bullet through the air. But light doesn't care what anyone decides. Its speed isn't tuned to anything, it's simply baked into the universe, like the rhythm of a lullaby no one remembers composing. You reach out with your thoughts and picture a beam of light sliding through empty space, no engine, no drag, no friction, just pure motion. It doesn't need. It begins fast, stays fast, and ends if it ever ends at the same pace it started. So why that number? Here's the quietly fascinating part. In physics, the speed of light isn't just about light. It's about information. It's the fastest anything matter energy. Signal can't travel. If the universe were a vast, sleepy ocean, light would be the swiftest ripple that could spread across its surface. This number, this strange, specific number shows up everywhere. It's in the equations that describe electricity and magnetism. It's in Einstein's famous E equals mc. It's part of the architecture of space-time itself. In fact, many physicists don't even think of it as the speed of light anymore. They just call it c, a fundamental constant as woven into the cosmos as gravity, or mass, or time. And here as a soft thought to lower your mind a little further. Light doesn't even need a medium to travel through. Sound needs air. Waves need water. But light just goes through nothing, across vacuum, like a whisper that never fades. Even in the absence of ears to hear it, you imagine now what it might feel like to be light. Not just to move fast, but to move at the speed of causality itself. To live in a way where the time doesn't pass, where there's no before and after, just a pure, eternal now. From light's point of view, there is no journey. A photon emitted from a star and one that reaches your eye have experienced. Nothing, no time, no in-between. Just a jump, a blink. Emission and arrival are the same moment. And this isn't poetry, it's physics. Which leads us to an even stranger thought, soft but electric. The reason nothing can go faster than light might be because faster has no meaning in this universe. Nothing can exceed the speed of light because nothing can transmit information more quickly. If you could, you'd be breaking causality. You could send a message before it was written, undo an event before it happened. You'd unravel the story of the universe like pulling a thread from a dream you weren't supposed to remember. So maybe the speed of light isn't arbitrary at all. Maybe it's not chosen, it's imposed. Not by a god or a designer, but by the very logic of the universe. A boundary drawn not in space, but in meaning. You shift a little in your thoughts, finding a more comfortable groove in this puzzle. Because if this limit weren't here, what would change? Well, for starters, nothing would make sense. Literally, things wouldn't be able to cause other things. An explosion on the moon could reach your eyes before the explosion even happened. A tap on your shoulder could ripple backward in time. The universe, in its silent logic, might not survive the noise. So instead, it gives us this, a speed limit not as punishment, but as protection. The rules of reality need a way to keep time flowing gently forward, not slipping back into And here's something subtle, almost shade that you might not have noticed before. This number, this speed, this cosmic pace. It's not actually about how fast light goes. It's about the structure that makes motion possible at all. It's the scale at which space and time are linked. You can even measure it in seconds and meters, but that's just our language, not the universe's. In some natural units used by physicists, the speed of light is simply one, not fast, not slow, just the base unit of all speed, a reference, a quiet standard set by reality itself. So when you hear someone say, nothing goes faster than light, it's not because we haven't built a good enough rocket. It's because the idea of faster doesn't exist beyond light. It's the ceiling of meaningful motion. The fastest that reality can move information from one place to another. You pause in your orbit, not literally but mentally. The stars still beam, your breath stays slow, and you begin to feel the edges of the question softening. Maybe the speed of light isn't a number we're supposed to solve. Maybe it's a lullaby we're meant to listen to, a quiet hum that says, this far, no farther, not because you're unwelcome, but because beyond here is a place with no rules, no order, no time, just. And so, the speed of light remains not a challenge, but a gift, a boundary that gives rise to story, to sequence, to cause and effect. You drift on, now wrapped, not in confusion, but in. There's something deeply reassuring about knowing the universe doesn't allow shortcuts, that no matter where you are, or how fast you travel, the fabric of existence remains tightly stitched by light's eternal pace. You're still floating, as softly as ever, surrounded by the gentle silence of space. Time seems to stretch and yawn in every direction. You're not hurrying anywhere, and neither is anything else. Except, perhaps, light. Light is the quiet overachiever of the universe, always moving, always on time, always holding itself to a standard no one else can match. And tonight, you're chasing it. But as you pick up imaginary speed, drifting in your mind behind a photon, something peculiar begins to happen. No matter how fast you try to go half the speed of light, 3/4, 99% you never gain on it. It still zips ahead, indifferent to your efforts. This is on just a quirk of motion. There's one of the deepest truths in all of physics. The speed of light is not just fast, it's you could build the most advanced spaceship imaginable, powered by dream fuel and propelled by equations still unproven. You could fire it across the galaxy with infinite ambition. But no matter what, you'd never get closer to that speeding beam of light. It would always be just out of reach, like trying to catch a shadow by running faster than it. And here's where the wonder deepens. Let's say you do build this ship. You accelerate until the stars begin to blur. Your engines roar out loudly. Of course, not in space but with power. You're moving at 90% of the speed of light. Then 99%. Then 99.9%. You glance at the light beside you and still, it races ahead. You'd expect, logically, that the light should seem to be moving slower from your point of view. Like how a car driving beside you on the highway seems to crawl forward slowly, even if you're both going fast. But light doesn't behave that way. Even at 99.9999% the speed of light, from your perspective, that photon still moves away from you at full speed. Exactly the same speed as if you were sitting completely still. How can that be? This is one of the cornerstones of Einstein's theory of special relativity. It tells us something strange and beautiful. The universe conspires to always show you light moving at the same speed. No matter how fast you go, or where you are, or how you're moving, light doesn't change. Instead, the universe changes around you. Time slows down, distances shrink, mass increases, reality bends and contorts. Not because light is breaking the rules, but because the rules bend to protect the speed of light. It's almost poetic, isn't it? Light moves with such commitment that the universe itself reshapes to accommodate its loyalty. It's the one thing that won't compromise. You lie back in your mind, floating still again. The chase paused. You think about how odd this is, how unintuitive. If you were flying behind a bird, you'd slowly catch it. Even sound can be outrun if you go fast enough. That's what a sonic boom is, the sound catching up after the plane has passed. But light, you can never break through. There is no visual boom, no catching up to the flash. The cosmos has written it into the code. This is the fastest information can travel, the fastest anything can travel. You can approach it, but never reach it, and certainly never go beyond it. In fact, every time you try to get closer, the cost gets higher, not just in fuel or energy, but in how your own reality changes. Time starts crawling, mass begins to swell, space itself seems to compress in the direction you're moving. It's as if the universe is softly but firmly saying, and here's something to gently twist your mind even further. The closer you get to the speed of light, the less time passes for you. In theory, if you could travel at light speed, remember, you can't, because you have mass you'd experience, no time at all. From your perspective, the start and the end of your journey would be simultaneous. This is what we meant earlier when we whispered that light is timeless. A photon doesn't age. A beam of starlight that began its journey 1 billion years ago arrives at your eye just as fresh as the moment it was born. It doesn't experience the journey. It simply is. You think again about that beam you were chasing. You didn't catch it, not even close. But now you understand why. It's not because you're slow. It's because the universe is structured to protect that barrier. Not for light's sake, but for time's. For cause and effect. For the delicate unfolding of past into present into future. You float again. Slower now. Not trying to chase anything. And in the stillness, you wonder about the implications. If no ship can ever catch light, then the stars we see are always seen in the past. You never see a star as it is, only as it was. In some way, everything you see is already gone. Already changed. You're watching the echoes of a moment, not the moment itself. Even your own reflection in a mirror is technically delayed just by a few nanoseconds, but delay nonetheless. And yet, light still connects you to those distant things. 2 galaxies, and supernova, and comets arcing around invisible suns. Light makes them visible, reachable, even if they can never be caught. You begin to feel grateful for light's loyalty. It doesn't hurry, it doesn't cheat. It just keeps going, carrying messages across eons and emptiness. It makes the universe visible to itself. It is the great storyteller, and also the limit on how quickly stories can be told. You're not chasing anymore. You're listening. You let the photon go, outpacing even imagination, and you close your eyes. The universe, it seems, always respects the rules of its own game, and that includes never letting you catch up to the messenger. Time, as you've always known it, is steady. It ticks forward like a gentle metronome. Seconds, minutes, hours, predictable, familiar. But tonight, we're going to watch that rhythm shift. Not wildly, but subtly, curiously. Like a dream where clocks start to melt a little around the edges. You're drifting again. Now inside that near light speed spaceship of the imagination. Out the window, Stars bend into streaks of white. The cabin is silent, serene. But something is different. Your body still feels calm, your breath still slow, but your watch, it's lagging. Compared to everyone else, your time is moving more slowly. This is one of those strange but experimentally verified effects of special relativity. When you move fast, really fast, time itself begins to slow down for you. It's not an illusion, it's not just how things look. It's real. Time is passing more slowly on your ship than it is for your friends back home. They age. You don't as much. Imagine that, taking a journey that lasts just a few years for you, only to return and find that decades have passed for everyone else. This isn't science fiction, it's called time dilation, and it's been measured with real atomic clocks flown on high-speed jets or orbiting Earth aboard satellites. The effect is tiny at those speeds, but it's there. And the faster you go, the more dramatic it becomes. You glance down at your wrist. The seconds there feel soft, sir. Meanwhile, back on Earth, calendars are turning, birthdays are passing, and the world is moving on. And yet, inside your ship, everything feels normal, because it is. To you, your time feels consistent. Your heartbeat doesn't slow. Your thoughts don't stretch out. It's only compared to someone else, watching from outside your motion, that time appears distorted. This is the universe's quiet compromise to preserve the constancy of light. Remember how we said light's speed stays the same for everyone, no matter how fast they're going? Well, this is how the universe makes that possible. It bends time itself to protect that law. You start to see it now, don't you? Speed isn't just about motion through space. It's also about how fast you're moving through time. When you're at rest, you move only through time. 1 second per second, simple. But when you start to move through space, the universe takes a little bit away from your motion through time. It slows your clock just enough to keep the books balanced, because the total motion through space and time can't exceed the speed of light. This is one of those moments where physics and poetry start to rhyme. You're not just moving in the universe. You're moving through its fabric, through space-time, and go faster in space, go slower in time. It's like a traveler on a long, narrow path. The more you zigzag across the width, the less ground you cover moving forward. Except in this case, the path is time, and the width is space. Even stranger, light itself doesn't travel through time at all. From a photon's perspective, it has no passage of time. It is born and it arrives instantaneously. There's no ticking clock aboard a beam of light. No past, no future. Just now. You think about this as your imaginary ship hums along. You look out again, and you begin to see not just stars, but histories. You're racing past photons that began their journeys before Earth even existed. And yet, to those photons, their trip took no time. You wonder, then, what is time, really? If it can stretch and bend, if it can pass differently depending on how you move, is it even real? Scientists debate this still. Some think time is an emergent property, something that only arises because of how we, as conscious beings, interpret change. Others argue that time is fundamental, a woven thread in the cosmic tapestry. But everyone agrees on this. Time is relative, not in a vague or metaphorical way, but in a literal, measurable one. And if time is relative, then so is reality. You lie back and smile, not because you understand it all, but because you don't. There's something deeply comforting about a universe that doesn't hand you all the answers, that leaves a little room for wonder, for slow thoughts, for drifting. You remember stories of astronauts who lived aboard the International Space Station for months at a time. Their clocks ran just a tiny bit slower than those on Earth by fractions of a second, but still, it's there. Proof, in numbers, that time is not fixed. It's more like a soft rubber sheet than a rigid ruler. And you're on the extreme version of that journey now, a traveler not just through space, but through rhythm itself. Imagine coming home and finding the world aged while you remained nearly the same. A quiet tragedy, or a kind of gift. You're not sure, but you know one thing. You'd never see time the same way again. And now, as you power down the engines and let the ship coast, you watch the stars slowly return to their crisp pinpoints. The streaking lines dissolve, the universe exhales. You wonder if maybe, just maybe, light isn't the fast thing. Maybe we're the ones who move slowly. Through time, you're coasting now, still in your quiet ship, moving gently through a universe that bends for no one but still somehow cradles you in curiosity. Behind you, the roar of imaginary engines has softened to a hush. Ahead, the stars are still watching. But something's changed. You've just lived through a soft stretching of time, and now you're going to feel space bend with it. Because when you move fast, time slows down, but space, it shrinks. It's called length contraction, and it's as strange as it sounds. The faster you go, the shorter distances become, in the direction of your motion. You imagine it like this. The universe has quietly rolled itself tighter, so you don't have to work quite as hard to cross it. As if, in sympathy with your effort, reality does a small favor and squeezes together. Just a little. It's not something you notice while moving. Your ship doesn't feel crushed. and your window doesn't get narrower. But if someone back on Earth could peer into your journey, they'd see your ship squashed, lengthwise shorter than it was at rest. A kind of cosmic optical illusion. Only it isn't an illusion at all. It's real, physical, measurable. This is the partner effect to time dilation. If time must change to protect the speed of light, so must space. They're not separate things anymore. They're one connected whole. And in this joined-up fabric, motion doesn't just pull at your clock, it stretches and folds the ruler you use to measure distance. Picture a road that gets shorter the faster you run on it. That's what the universe does for objects approaching light speed. What was once 1,000 light years might be a fast-moving ship feel like only a few dozen. From your perspective, you're not cheating. You're simply taking the shortest path that time and space now allow. You smile at this because it's just so odd, and yet so elegant. Faster motion shortens your path and slows your time. It's almost as if the universe is whispering, yes, you may go far, but it will feel like less time to you, and more to those you leave behind. There's a kind of philosophical ache in that thought. Imagine leaving Earth, accelerating until your journey is just a blink to you, while decades or centuries pass for those watching. You return to a world changed while you've barely aged at all. Science fiction is filled with stories like that. Explorers who come home to find their children old, or their planet gone, or the world unrecognizable. But tonight, we're not chasing drama, we're resting in the science. And the science says this: time and space are not constants. They're stretchable, pliable, woven together by motion. And at the heart of it all is the speed of light, the speed that everything bows to, the pace that space-time rearranges itself to protect. You look again at your ship, its sleek edge now subtly shorter to distant eyes. It's like a dream folded over itself, compressed just enough to fit in your pocket. To you, it feels unchanged. But from the outside, it's part of a shifting universe, always recalibrating, always adjusting. There's something comforting in the idea that reality is not rigid. It yields not in ways you can manipulate with a hammer or a scream, but gently, under the guidance of motion. It's like watching a quilt ripple as you move across it. You're not tearing it here or coasting through, and it's flexing around you, helping you along. And here's a curious aside. This length contraction isn't just for spaceships. It applies to everything. Even protons and particle accelerators. When they zip around at near light speeds, their shape contracts. We don't see it with the naked eye, but the math tells us it's real. So does this mean your toothbrush shrinks ever so slightly when you wave it quickly through the air? Technically, yes, but the effect is so unimaginably tiny at our everyday speeds that it doesn't matter. Not unless you're brushing your teeth at 99.999% the speed of light. If you are, you've probably got bigger things to worry about than toothpaste. Still, the principle holds. Space shortens under motion, and light speed is the threshold beyond which this shortening would no longer make physical sense. But of course, nothing with mass can reach that threshold. As you approach it, the contraction becomes extreme, the time dilation immense, and the energy required to go just a little faster becomes infinite. It's the universe's way of saying, you may fold the dream, but you cannot tear it. You start to see a theme forming. No matter how fast you go, no matter how much the universe warps around you, it's always in service to this one rule. This one speed. Light is the silent metronome behind the music of reality, the tempo that space-time dances to. You float again, relaxed, letting your thoughts swirl around the edges of this idea. Maybe speed isn't the wild race it seems. Maybe it's more like a gentle reshuffling, a play of distance and duration. Maybe moving fast just means living differently, experiencing space as a little shorter, time is a little slower. And maybe, in the end, you don't really travel through the universe. Maybe the universe travels through you. Each contraction, each soft reshaping of the world is just reality, adapting to your movement like water forming around your hand. You reach out, slow and dreamlike, and feel that same ripple of space-time ease beneath your fingers. You're not breaking anything. You're just drifting gently through the rules. You're floating now with an odd sense of resistance, not in your body, but in your thoughts. Something invisible seems to push back, just a little, as if the universe itself is trying to tell you. You've slowed down your imaginary ship, but your mind still hums with momentum. You've felt time stretch and space compress. But now comes the next strange truth. Mass doesn't like to move fast. The faster you try to accelerate something, the more stubborn it becomes. You could pour in more and more energy, fire all the thrusters you can imagine, and still your ship just gets heavier. Not in the usual fall to the ground sense, but in a deeper, more cosmic way. Its resistance to acceleration increases. Its inertial mass rises. You begin to understand this isn't a flaw. It's part of the same elegant system that protects light supremacy. The universe has a built-in safeguard against breaking its own rules. As you get closer to the speed of light, each little push you give requires exponentially more energy than the last. It's like trying to run through syrup, and the syrup gets thicker with every step. Eventually, no matter how much fuel you pour in, you gain almost no speed at all. You're pushing against the very fabric of reality, and reality is pushing back. This is why no object with mass can reach light speed. Not because we haven't built a fast enough rocket, but because the energy required would be infinite. It's not a limit of technology. It's a limit of the universe, and you're just a traveler within it. Curious, small, respectful of the invisible walls that shape the dream you're floating through. You turn your attention to everyday things. A baseball thrown, a train accelerating, a person running. Each one feels the pull of inertia. It's subtle at low speeds. A slight reluctance to change direction or speed, but it's there. Now magnify that reluctance a billionfold. That's what a ship near light speed feels when it tries to go faster. You think again of Einstein's equation, E equals mc. You've heard it before, probably since childhood. But now, the quiet gravity of it begins to settle into your chest. It means mass and energy are deeply connected, that anything with mass is a form of stored energy, that the faster you try to move something, the more energy it contains, not just as kinetic energy, but as a kind of mass, like the ship itself is quietly gaining weight as it speeds up, as if the cosmos is whispering, enough. Now, the deeper you go into this idea, the more intimate it feels. You're not just an observer, you're part of the equation. Your body, your atoms, your cells, they all hold mass, and that means you, too, resist sudden change. You've felt it, standing still, then sprinting. The jolt, that's your mass reminding you that motion must be earned. And now, from your spot in space, watching the stars shimmer without urgency, you understand why this resistance matters. If mass didn't resist motion, everything could move at the speed of thought. Rockets would coast to other galaxies, and worse, causality itself might break down. There'd be no time to react, no space between action and result. Instead, the universe says, wait, push gently, earn every motion. And you do. You imagine pressing the ship's controls, trying to accelerate just a little more, but you feel it. That growing weight. The effort isn't in your fingers, but in the laws of physics. It's like asking a hill to become flat. The universe won't say no, but it will make it harder and harder until you simply stop asking. And here is a delicate thought to carry with you. Even though you can reach light speed, you can approach it. You can get so close that the difference is like measuring the edge of a snowflake with a yardstick. And when you're that close, the effects are dramatic. Time slows, space contracts, mass increases. The ship begins to feel less like a vehicle and more like a question you're asking of the cosmos. What happens if I go just a little faster? And the cosmos replies, with a gentle hand on your shoulder, not here, not now. You breathe out, slow and steady. The resistance isn't frustrating, it's grounding. It reminds you that the universe is not a race. It's a long, unfolding story. And like any good story, it needs pacing, structure, limits. You think again of photons, the massless messengers of light. They feel none of this. They don't push, they don't resist. They simply are fast, eternal, effortless, but they're also simple. They carry no baggage, no rest mass, no memory, no struggle. You, on the other hand, are made of heavier stuff. Literally and metaphorically, you have mass, you have history, you leave impressions. You affect the things around you. You might not move as fast, but you move with meaning. And maybe, just maybe, that's the trade-off. Speed without mass, or mass with depth. The ship begins to slow again, not out of failure, but because the point has been made. You've felt the resistance, not as punishment, but as a lullaby. The kind of limit that protects more than it denies. So now you drift again, letting go of speed and effort, just breathing. And somewhere in the stillness, the universe breathes back. You drift now in a kind of wonder, surrounded by the soft hush of an eternal night. Stars whisper from every direction, and in their light, there is something peculiar, something that never tires, never ages, never slows. Tonight you get closer to the photon, the universe's most delicate traveler, massless, timeless, always moving, always at the same speed, no more, no less. And as you imagined it, this tiny packet of energy, this flutter of electric and magnetic fields, you start to realize a photon can't stop, not just because it refuses to, but because it's physically impossible. Stopping would mean it has to exist at rest, but a photon isn't built for rest. It only exists as motion. Its entire identity is woven into speed. If it were to stop, it would cease to exist. It's strange to think of something so essential, but that's exactly what makes it special. Light doesn't just travel fast. It must travel fast. It only exists at the speed of light, not before, not after, only as. And unlike your ship, which pushed harder and harder to get even a little faster, light does it effortlessly. Not because it's powerful, but because it carries no mass. This is the cosmic loophole. Massless particles don't need to be pushed. They simply are. And their speed isn't a choice, it's a condition of their being. You're not just imagining this photon flying through space, you are it. Now, just for a moment, there's no up or down, no past or future. You aren't on a journey. You are the journey. No seconds tick by. No distance is felt. You are emitted, and then absorbed, instantly. as if space and time folded into a single point. To every other observer, you took years, decades, eons to arrive. But to you, the photon there was no duration, no passage, just the endless now. And this leads to one of the strangest, sleepiest truths of all. Light never experiences time. It travels across the universe, but it doesn't age. A beam of starlight from the Andromeda galaxy has traveled 2.5 million years to reach your eyes. But from the light's point of view, it left Andromeda and arrived here at the same moment. Not just quickly, instantaneously. It's hard to imagine, but that's the power of being massless. Time doesn't stick to you. You're free from it, untouched. And in this freedom, there's a kind of haunting simplicity. Photons don't change, they don't rest, they don't hesitate. They are born moving, and they vanish the moment they stop interacting. Do you think of all the places photons visit? The deep belly of a star, where they're created in chaos and pressure, bouncing around for thousands of years before finally escaping to open space. The surface of your skin on a sunny day, the glint of a moonbeam on water. Every photon tells a story without ever writing it down. And while you're in this floating reverie, something else occurs to you. Photons don't carry time, but they carry energy. And that energy depends on their wavelength. A blue photon has more energy than a red one. A gamma photon can slice through atoms. An infrared one just warms your cheek. Different vibrations, same speed, always the same speed. And this energy, it's not stored in the photon. The photon is the energy, a little ripple of the electromagnetic field, moving forward because that's all it can do. And here's another sleepy, stargazing fact to carry with you. Even though photons are massless, they still carry momentum. They can push things, slowly, gently, but undeniably. It's called radiation pressure, and it's real. Solar sails, one day, might carry future explorers across space using nothing but the subtle push of sunlight. Think about that. Light, with no mass, no rest, no time, can still move things. You begin to smile. Light, the softest traveler, leaves fingerprints. It cannot age, it cannot stop, and yet it changes the world as it passes through it. You picture a single photon again, crossing the void. It doesn't know, but it is, in some way, pure. It's not distracted, not weighed down by questions. Just moving, just carrying energy and information from one place to another. And that, in itself, is beautiful. Because in this quiet simplicity, the photon becomes the perfect messenger. It doesn't need to be fast, it is fast. It doesn't fear the future, it doesn't even have a future. And it never, ever gets tired. You settle deeper into your floating frame of mind, letting this tiny cosmic traveler guide you. Maybe there's something to learn from the photon. Not to rush, but to move with purpose. Not to fear the passage of time, but to understand that it moves differently for different eyes. And perhaps most of all, to know that even the gentlest thing, something without mass, or form, or substance, can still cross the universe, still touch the stars, still leave light in someone's eyes.
You're adrift again, coasting softly through a sea of stars, with photons still flickering in your thoughts. They feel less like particles now, and more like promises, beams of energy that always keep moving forward, never resting, never breaking their word. But how do we know that nothing can move faster than them? Tonight, you settle into the deep calm of that question, because the truth is both elegant and quietly stubborn. The universe has made a promise too. Nothing with mass can reach, let alone exceed, the speed of light. This is not just a claim. It's a rule so deeply built into reality that all of modern physics, from the behavior of tiny particles to the bending of galaxies, follows it. And it began softly, radically, with Albert Einstein. In 1905, he proposed that the laws of physics are the same for all observers in uniform motion, and that the speed of light is constant in all frames of reference. Now that might sound like a quiet observation, but it changed everything. If light's speed is always the same, no matter how fast you're moving, then space and time must adjust themselves to make that possible. That means time can slow, space can contract, and mass can grow, all to preserve that one constant. It's as if reality reshapes itself, not to protect light, but to protect the principle of light's speed. You might wonder, though, couldn't something just go faster anyway? Couldn't we build a ship clever enough to punch through the barrier? But here's the thing. The speed of light isn't just a speed. It's the maximum speed at which cause can lead to effect. It's the fastest that any interaction, any signal, any information can travel. If you could go faster than light, you could do something strange. You could send a message into the past, arrive at a destination before you ever left, undo the falling of a glass after it hits the floor. You would shatter causality. The universe gently but firmly refuses to let that happen. So instead, it makes light speed a wall. It's not made of stone or metal, but of math and logic. unbreakable, implacable. There's no getting around it. Not because we lack the tools, but because anything faster wouldn't make sense. You float back in your imaginary ship and remember all those sections of space you've passed. The contraction of distance, the slowing of clocks, the resistance of mass. All of it is the universe's way of telling you, this far and no farther. And here's where the story gets even more poetic. Einstein's theory, special relativity, doesn't just say light has a limit. It says the structure of reality depends on it. The geometry of space-time, the behavior of energy, the connection between motion and mass, all of it bends gently around this speed. It's not a cap slapped on top. It's a foundation resting beneath. And yet this truth is so easy to overlook. After all, in your day-to-day life, nothing seems to move at light speed. You walk, you drive, you blink. No object you can touch or throw ever reaches anywhere near it. But when we look out into the stars, or deep inside atoms, we see this rule holding firm. Everywhere. Always. Particles and high-energy accelerators get closer and closer to the speed of light, but never reach it. It's like chasing a horizon that keeps stepping away. You can get within a breath of it, but no matter how much energy you pour in, the finish line never lets you cross. And here's something even quieter, even stranger. This speed limit doesn't just apply to light. It applies to any interaction that spreads across space. Electromagnetic waves, gravitational ripples, neutrinos flying from exploding stars. Nothing can carry information or influence faster than light. The universe speaks many languages, but they all travel at the same pace. You tilt your head, imagining what this really means. It means that when a star explodes in a galaxy far away, you don't feel its effects instantly. The light, the neutrinos, the gravitational waves, they all take time to arrive. Even the laws of physics must wait for their turn to act. And this delay, this pause between cause and effect, it's not a flaw. It's what makes things make sense. You feel it now, not as a hard edge, but as a soft curtain that ensures reality unfolds in the right order. A kind of cosmic pacing that keeps the story straight. And maybe that's why the speed limit isn't meant to frustrate us. It's meant to shape us. We are built within it. We learn, grow, remember, and dream under its ceiling. Our hearts beat in rhythms shaped by light and delay. Even your thoughts right now, the way they unfold one after the other, follow this same choreography. Cause then effect. Question then answer. A slow-motion dance across space-time. You think again of that photon. So fast, it never experiences time. But you do. You get to feel the passage, the unfolding, the gentle ache of before becoming after. And isn't that a gift? To live inside the story, to feel time stretch behind and ahead, to be bound by the same speed limit as everything else, and still find meaning in the waiting.
You're floating again, this time near something heavier, something massive and slow and strange. A planet? No. Bigger. A star? Still no. A black hole. And here, near the edge of one of the most mysterious objects in the universe, the speed of light is more than just a number. It's the shape of reality itself. You ease your mind toward the curved horizon of the black hole called the event horizon, where gravity becomes so strong, so intense, that even light can't escape. Not because it's too slow, but because space itself is curved inward, like a soft funnel with no bottom. This isn't a wall. You could cross it without feeling a thing. No flash, no tremor. But once you pass that line, there's no way back. Not for a spaceship, not for a photon, not even for time itself. This is where space-time bends so steeply that all paths lead inward. The speed of light is still the limit, but now all directions point toward the center. Forward, backward, up, down. It all means in, and you begin to see. Gravity doesn't pull like a rope it shapes. It sculpts the geometry of like pressing your hand into a soft mattress. It creates curves, and light, ever obedient to the rules, follows those curves perfectly. Even when it leads straight into darkness, you're hovering near the edge, watching how light behaves in this distorted zone. Beams that would normally fly straight now bend like lazy river currents. Some circle the black hole in perfect orbits, caught forever in a loop. Others stretch and lean as they try to break away. But the closer they get to the event horizon, the more stretched they become. Their wavelengths lengthen, redden, fade. This is called gravitational It's like trying to climb out of a deep gravity well, and slowly losing its energy along the way. You realize something quietly profound. Gravity slows time, too. Clocks tick more slowly in stronger gravitational fields. And here, right near the black hole's edge, time becomes almost still. If you stood safely far away and watched someone fall toward the horizon, you'd never see them cross it. They'd appear too slow, freeze, fade into red, and vanish. But from their point of view, they fall smoothly, in real time. No drama, no pause. It's only from the outside that time seems to stop. And this leads you to a deeper truth. The speed of light stays constant, even here, but space-time itself is twisted around it. That's the genius of Einstein's general relativity. It says, gravity isn't a force pulling on things, it's a bending of the map. Mass tells space-time how to curve, and space-time tells matter how to move. And light is the most obedient traveler. It always follows the bends exactly. Never questions, never resists, just flows. Even if that flow means disappearing into a place where time stops and meaning becomes murky, you float closer, gently. You're not afraid. The black hole isn't evil or malicious. It's just deeply different. A place where the usual rules become more flexible, where even the idea of direction up, down, forward loses clarity, and you notice something else, something quiet and oddly comforting. Even here, the speed of light remains the universal speed limit. No matter how twisted no matter how extreme the mass, light is still the fastest signal possible. That rule doesn't break, not even for a black hole. Instead, what changes is the structure light has to move through. Like a river diverted by shifting Earth, photons here find their paths bent not by resistance, but by geometry. And that geometry, it's defined by mass, by presence, by the way energy distorts the grid of existence. You realize, then, that even space isn't empty. It's flexible, responsive. It's not a blank canvas, but a surface that flexes with every presence, every mass, every movement, and light dances across that surface. You remember something simple now. Gravity is everywhere, not just in black holes, but in every quiet orbit, every falling apple, every shift in your own body weight when you breathe in. And so, the speed of light isn't just a rule of movement, it's a limit written into the shape of things, a boundary that defines what is possible, not in opposition, but in harmony. You lie back in your thoughts, floating farther now from the black hole, watching it shrink to a quiet pinprick in the distance. Not a threat, just a lesson. You've seen now how gravity doesn't challenge light, it redefines the roads, it moves on. And light, always steady, never breaks the rule. Even in places where time nearly stops, where space turns inward on itself, and where distance loses meaning, the speed of light remains the same. And with that thought, you find something rare, a calm center in a universe that never stops shifting. Because even when the path bends, the traveler stays true. You drift now into the foggier regions of physics, the places where the lines between certainty and wonder begin to blur. We're leaving behind the solid curve of space-time and stepping into something stranger, softer, more uncertain tonight. We peek into the quantum world, the world of particles that don't sit still, where position is a suggestion, not a statement, where cause and effect sometimes wear each other's clothes. Here, nestled among the gentle probabilities and quiet paradoxes, the speed of light still rules, but not in the way you might expect, because in this realm of uncertainty, particles sometimes seem to cheat. They take shortcuts, they leap, tunnel, flicker, vanish, and reappear faster than light should allow. You watch now not with a telescope but with your mind. There's a wall, a barrier. A quantum particle, an electron, maybe hovers on one side. It doesn't have enough energy to cross the barrier. It shouldn't be able to. But in the quantum world, shouldn't is only a guideline. The electron disappears from the side of the wall, and reappears on the other. No break, no trail, just a sudden, soft jump. This is quantum tunneling, and the strangest part, it happens in zero time, not just quickly, not just nearly instantly, but according to some interpretations faster than light could make the same trip. And that, understandably, raises eyebrows, because we've spent this whole journey respecting the speed limit, trusting it, learning from it, believing it holds the cosmos together. So how can a particle just skip across time and space? Here's the soft answer. It doesn't carry information. When it does, the speed of light isn't just about how fast particles can move. It's about how quickly information can be transmitted, messages, influence, causality, and in the strange little world of quantum mechanics, particles can behave in ways that look like cheating, but they never actually send a signal faster than light. No one receives anything. No message arrives before it was sent. It's more like possibilities rearranging themselves, like flipping a coin that shows heads on both sides, but never tells you which way it flipped. You float closer to another mystery. Entanglement. Two particles become connected not physically, but infinitely. You measure one, and the other responds instantly. Across miles, across light-years. It looks like a faster-than-light handshake, a secret code passed without delay. But again, no information travels. You can't use entanglement to send a message. You can't cheat causality. It's correlation, not communication. A cosmic mirroring, not a whisper. Still, you wonder if something looks instantaneous, doesn't that still bend the rules? Physicists debate this. They build experiments and argue softly in conference rooms. But no one has yet found a way to use these quantum quirks to violate the speed limit in any meaningful way. The photon remains king. Its pace is still the fastest road any message can travel. And the quantum world, it's not disobedient, it's just uncertain. Particles don't defy the rules. They live in a blur of options. And when they finally commit to one, it's always in a way that respects light's authority. Even tunneling doesn't break the limit. It just dances around our expectations. You float now through this quantum, a field where emptiness is alive with fluctuation. Tiny particles popping in and out of being, virtual particles exchanging silent glances before vanishing again. And here, something even softer happens. These fluctuations, these temporary particles that can borrow energy for brief moments, as long as they return it quickly, like a polite guest borrowing a coat and returning it before the evening ends. Some of these particles even seem to travel slightly outside the usual path, off the beaten trail of time and space. A whisper, not a shout. A ghostly presence that never quite materializes, but again, no messages, no cheating, just the rules, gently warped like a lullaby played in an odd key. You begin to see now that speed, in the quantum world, is more about probability than pace. Particles don't travel neatly from A to B. They explore every path, then only reveal the one they took when asked. And that path, while sometimes faster in appearance, never violates the ultimate law. You're smiling now, because this feels like a kind of play. The universe, so precise on large scales, is delightfully unpredictable on the smallest ones. And yet, even here, even in this fog of uncertainty, the speed of light holds. It isn't a fence. It's a thread, a golden ribbon through chaos. You settle back again, the quantum fuzz fading behind you, leaving only a quiet respect. It turns out, even in the places where the rules look like suggestions, the universe still whispers the same promise. No cause without effect. No message without meaning. No faster path than light. And isn't that oddly reassuring? In a world where particles flicker and tunnel and blur, the one thing that never wavers is the limit. You're drifting through thought now, slower than before, and deeper. You've traveled across space-time and quantum fields, through mass and motion and mystery, but now, in the quiet of your curiosity, you begin to wonder about something that exists, mostly in stories, whispers, and dreams and pages of theoretical math. You wonder about tachyons, particles that, if they existed, would always move faster than light. Not sometimes, always. You don't see them in nature. They've never been observed, but they live in equations, lingering like ghost notes in the music of physics. And tonight, we'll meet them not as facts but as ideas, dream particles, hypotheticals that ask, what if the speed limit wasn't a ceiling, but a floor? You ease into this idea the way you might drift into sleep, slowly, curiously, without expecting to find all the edges. Tachyons, as imagined, would never be able to slow down below the speed of light. They'd always remain on the other side of that cosmic wall, always faster, always out of reach. And here's the strange part. The math that describes them works, sort of. If you plug in imaginary mass, yes, literally an imaginary number from mathematics, certain equations seem to allow these particles, but allowing something mathematically isn't the same as finding it. In the wild, tachyons have never shown up in experiments. No detectors have caught them. No telescopes have glimpsed them flying from deep space. Still, the idea remains. And what an idea it is. A particle that travels so fast that, from your point of view, it might arrive before it left. Cause and effect tangled into knots. Send a tachyon signal to a friend, and they might receive it before you sent it, or respond to your message before you even thought to write it. And that's why physicists are cautious, because tachyons, if real, would undo the most sacred order in science. Causality, events must happen in sequence. One thing causes another. This leads to that. You flip a switch and then the light comes on, not the other way around. But with tachyons, the very structure of time might fall apart, or at least rearrange itself into something weirder, looser, less directional. And yet, not all scientists dismiss them completely. Some theories flirt with the idea, especially in early universe physics or speculative fields like string theory, because in math, sometimes it's helpful to imagine things that can't exist, just to better understand what can. You lie back, thinking about this, a universe where certain things are so fast, so untouchable, they bend the timeline backward. And maybe that's why we don't find tachyons, because if they exist, they might never interact with our slower world. Like flashes from a dream that can't quite pass through the veil of waking life, you imagine one now, a tachyon zipping by, faster than comprehension. That doesn't pause, it doesn't leave a mark. But maybe it felt something from you. Maybe its own frame of reference was watching you in slow motion. As strange and improbable as you find it, it's a playful thought, a quiet sci-fi possibility tucked inside real science. And yet, the universe seems to prefer consistency. The more we test, the more light speed holds steady. No leaks, no shortcuts, just that same sacred limit always upheld. You feel a kind of comfort in that. Not everything that can be imagined needs to be real sometimes. The value of a wild idea is in how it frames the stable ones. Tachyons remind us what it means for something to move within our rules. They're not villains of physics, they're shadows of possibility, and there's something gentle in imagining them. Not dangerous, but poetic. A particle that lives too fast for time, too free for cause, too strange for our slow, deliberate world. You drift farther now, letting that concept fold back into the fog. No alarms, no alarms. Just wander back in your normal speed reality. Every photon you see, every signal you detect, still honors the limit. No tachyons have stepped out of hiding, no time-reversing messages have been received. Just light, soft and steady. The faithful messenger. And in that silence, in that order, there's a kind of peace. Because the universe we know, bounded and logical and beautifully timed, is one where things unfold gently, with cause, with rhythm, with light leading the way. And if somewhere beyond that rhythm tachyons dance, well, let them. We'll be here, moving a little slower, but perhaps, in our own way, with just as much grace. You floated through a universe of rules, of particles and paths, of light that never tires and space that softly bends, and now you find yourself somewhere quieter still. Not a place, exactly, but a signal, a hum, a whisper, a glow from the very beginning of everything. This is the cosmic microwave background, the CMB, and tonight you listen to it. The CMB is the faint afterglow of the Big Bang, the cooled remains of the first light that ever moved freely through the newborn universe. It's not loud, it's not bright, but it's everywhere, all around you, all the time. Not in any one place, but in every direction equally, like the softest music playing behind the stars. You don't see it with your eyes. It lives in the microwave spectrum, too long for your vision to catch, but you can feel its presence. Have even measured it as part of the static in old analog televisions. That gentle fuzz between channels, a piece of the beginning. And here's where the story circles back to the speed of light. Because the shape of this glow, the way it fills the sky, the way it stretches across time and distances directly shaped by light speed. You drift now, slowly, through the early universe. Not galaxies and planets yet, but a dense, hot fog of particles and energy. In these first 380,000 years, light can't travel freely. It keeps bouncing off charged particles, like a firefly trapped in a jar of fog. The universe is too thick, too hot. Photons can't go far without running into something, but then, a change, the fog clears. Atoms form. The universe cools, just enough, just in time, and suddenly light breaks free. This moment is called recombination, and it's when the cosmic microwave background was born that ancient light has been traveling ever since, stretching as the universe. It expands. What was once hot, glowing radiation has cooled to just a few degrees above absolute zero, but it still travels, still moves at light speed, still carries the imprint of the universe's baby steps. You imagine it now, softly rippling across space, not in a straight line, but in every direction. A vast spherical echo, growing fainter but never stopping. And we, here on our quiet little planet, have built instruments sensitive enough to detect it. We've mapped it, we've listened, we've turned it into picture-steeny colorful blotches that show where the early universe was just a little denser. Here, a little warmer there. Those blotches, they became galaxies, stars, US dots, and if light had moved at a different speed, just a little faster or a little slower, the structure of everything would be different. The way galaxies formed, the way matter clumped together, even the size of the observable universe, all of it is shaped by that constant pace. The speed of light isn't just a limit, it's a kind of chisel, carving the structure of everything that came after. You begin to feel how deeply connected everything is. That starlight you see tonight, twinkling through your window, it's part of the same continuum, part of the same story. Bought from the CMB to the beam from your bedside lamp, it's all one long slow song, played at a single tempo. You close your eyes, just for a moment, and imagine listening to the CMB in real time. If you could hear it not in sound, but in presence, it would be the background murmur of everything. A universal still here, a memory humming beneath the silence. And in that soft hum there's data. Tiny variations, not random but meaningful. Scientists call them anisotropies, and they're the fingerprints of the universe's first few moments. Differences in temperature, in density, tiny imperfections that seeded everything we now see. All of it sculpted by how fast light was able to move, how far it could get, how long it had to travel before structure could form. If light had moved faster, it would have smoothed out those differences too quickly. The universe would be flat, bland, empty. If it had moved slower, maybe those ripples would have collapsed too fast into black holes, or dense knots with no space for stars. But it moved just right, and here we are. You breathe in, slow and steady, letting that realization settle into your chest. The shape of the universe, the music of the stars, the spiral of galaxies, the comfort of gravity was composed by a speed that never changes, and even now, billions of years later, that early light is still traveling, still arriving. In a hurry, not delayed, just steady. It's a lullaby that never ends, and we quiet observers with our fragile eyes and wondering minds are lucky enough to listen. The universe is not silent, it's whispering, and its first word was light. You're lying still now, your thoughts floating weightless again through the dim, dependable glow of ancient light. You've followed photons from stars and from the beginning of time itself. And now, we return to something even stranger, something so counterintuitive that, once you hear it, you never quite forget it, no matter how fast you're moving. Light always moves at the same speed. Always. You could be sitting on your porch or speeding through space at 99.999% of light speed. You could be chasing after a photon with all your might, breathing hard through the engines of a hypothetical ship that bends space-time like a sheet of silk. And still, that photon pulls away from you at the same speed as it would if you were standing still. 299,792,458 meters per second. No more, no less. It's not slowing down for you, and it's not speeding up because you're coming toward it. It's just there, always the same. This isn't just strange, it's revolutionary. It's the beating heart of special relativity. And it's why everything we've explored so far, time dilation, length contraction, mass increase, has to happen. Because otherwise, the math doesn't work. The universe would unravel. You float deeper into that idea now. Try to imagine you're back in your ship again, coasting smoothly through the void. You flip on your headlight and send a beam of light ahead of you. Then, in your mind, you accelerate faster, 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 getting close to that sacred limit. Or you ask yourself, if I'm moving at nearly the speed of light, and I turn on a flashlight, won't the beam creep ahead of me more slowly? It feels like it should, but no. From your frame of reference, that light still moves away at full speed. You measure it, you chase it, you send more beams. Always the same result. The light refuses to budge from its sacred pace, like a stubborn but graceful dancer who always stays one step ahead. This feels impossible. It breaks the rules of how speed should add up. If you're running on a train, your speed adds to the train's. You go faster, but with light. The rules change no matter how fast the train moves. The light from your flashlight travels at the same speed for you and for someone standing still beside the track. So how does the universe make that possible? By changing everything else. Time slows, length contracts, mass increases, reality bends, not the light. It's like the cosmos is rearranging the stage set just to preserve this one quiet law. You might ask, why? Why would the universe be built this way? And here, there's no satisfying answer. No grand revelation, just consistency. When scientists discovered this, they didn't take it lightly. They tested it again and again through particle accelerators, satellite systems, cosmic observations. And every time, light speed held firm. It's not just a curious feature, it's a pillar. You lie still, letting the idea seep in through the folds of your imagination. This constancy, this unshakable sameness gives rise to all the strange effects we've explored, because light is always the same speed for everyone. The universe must allow different people to experience time and space differently. It's not an accident, it's not a glitch, it's design, not with intention, but with necessity. And here's the poetic part. This means there is no universal now. Two people, moving differently through space, won't agree on when things happen. They won't agree on what's simultaneous. The concept of at the same time becomes flexible, personal. Each observer carries their own slice of time, shaped by how they're moving. So while we may share space, we do not share the same present. We live in overlapping but personal nows, stitched together by the speed of light. It's beautiful, and a little bit lonely, but also comforting, because this universal limit ties all those nows together. It ensures that, even across vast separations of space, we all follow the same rule. You, the stars, the distant galaxies, the quiet satellite drifting above Earth tonight. We all measure light at the same pace. We're synchronized by that glow. And maybe that's why the universe feels ordered at all. Because beneath the chaos of motion and distance, there is a shared rhythm, a cosmic tempo. You're breathing slower. Now, your thoughts, too, have softened. The idea that we all live in relative time frames yet still share this one immutable constant. It's like music. Different instruments, different notes, but one key, one beat. And at the heart of it, light. Always light. You float a little more loosely now, the edges of your thoughts softening like a coastline fading in mist. But even here in this state of stillness, an old question rises up like a quiet ripple. Has the speed of light always been the same? It's a gentle rebellion, isn't it? After all, we've spent this whole journey learning how constant, how immovable, how sacred this speed is. The cosmic ruler, the boundary line, the limit no one, no thing, no signal can break. But what if it changed? Not just here and there, but once long ago, before there were galaxies, before stars, before even time felt like time. You drift into this idea cautiously, curiously, like peering over the edge of a very still pond. Some physicists, soft-spoken theorists working in the quiet corners of cosmology, have dared to ask, what if, just after the Big Bang, light traveled faster than it does today? What if the speed of light, back then, was different? This is more than a thought experiment. It's part of a real proposal called varying speed of light theory, or VSL, a theory that tries to answer certain puzzles about the early universe. Puzzles, like why is the universe so smooth and uniform, even in regions too far apart to have ever talked to each other? Why does it appear so flat, like a perfectly ironed sheet? Why do the laws of physics feel so coordinated? One explanation is inflation, a period of extremely rapid expansion. Another is VSL, what if light simply moved faster in the beginning, able to cross vast distances in the blink of a cosmic eye? You let that idea expand in your mind like a bubble, light, racing even faster than its current limit, not breaking the rules, but living before the rules solidified, like running before walking was invented. Of course, there's no direct evidence for this. We can't rewind the universe. We can't set up a lab inside the Big Bang, but the math allows it, under certain models. And just for a moment, you feel the walls of certainty flex. Not collapse, not break, but bend. Maybe light didn't always move the way it does now. Maybe the speed we call constant is really just stable. For now, think of the constants of nature like the strength of gravity or the charge of the electron. We call them constants because they never seem to change. They anchor the universe, but we've only been measuring them for a blink a few centuries, at most. What if we're watching a movie frozen on one frame and assuming the whole film looks the same? You don't have to believe it. Just imagine, light used to move faster, but over time the fabric of space-time thickened, settled, hardened, and now it flows at this steady familiar rate, not because it must, but because the universe cooled into it. That's one version of the story. Another says, maybe the constants really are constant. Maybe we've just found an elegant trick, a way to ask new questions without rewriting the old answers. You let both possibilities coexist in your thoughts. That's what good science does. It holds the known and the unknown side by side, like hands at rest. And even if the speed of light has always been the same, the idea that it might not have been is quietly thrilling. A whisper that says, even the most trusted truths were once discoveries. The poet in you smiles, because what could be more dreamlike than imagining that even the universe's speed limit had a beginning? That the laws we think are eternal might have once been in flux, shifting, stretching, catching their breath as the cosmos learned how to be a cosmos. It makes this moment to your moment feel not just small, but precious. You live in a universe where light moves just as it does. Not too fast, not too slow, just right, and perhaps that's no accident. Maybe we exist because the speed of light is what it is, because it gave stars time to form, gravity time to gather, atoms time to learn how to bond. You breathe a little deeper, because even if the speed of light could change, it hasn't. Not in the billions of years we can see. Not in the quiet hum of starlight or the delicate spread of galaxies. It's steady, faithful here, and maybe that's enough. You're drifting toward the end now, slowly. Gently, as if the universe itself were preparing to lower the lights. Your mind feels softer, quieter. The questions have slowed, and in their place, a kind of calm curiosity, the kind that doesn't need to be answered. You look around the cosmos one more time. It's still vast, still cold, still lit by the silent glow of distant stars, but now it feels different now. You can see the structure behind the shimmer, the hidden rhythm that gives the universe its shape, and it all seems to hum with a single ancient truth. The speed of light defines what can be. It's not just a limit on motion. It's a boundary for everything, for space, for time, for cause and effect. Without it, nothing would make sense. Without it, nothing would hold together. You return in your thoughts to the particle you met near the beginning, the photon. Weightless, timeless, tireless. Its motion sets the pace for the universe. It is not bound by time because it defines time. It cannot be at rest because it is movement. It doesn't choose to move at 299,792,458 meters per second. It must. That speed is not a cap, it's its very identity, and because of that one constant, everything else takes shape. Time flows, space stretches, energy spreads, stars shines. You think about the galaxies. Vast spirals burning for billions of years, light leaving their cores to begin long, graceful journeys toward us, knowing somehow that they'll arrive long after their birth. You imagine one of those photons born in the heart of a dying star. It slips free, travels through the emptiness, past clouds of gas, past other stars, past planets we'll never see, and eventually it reaches you. That touches your eye, or your telescope, or the lens of a camera that will share it with the world. That light, older than Earth itself, has moved at the same speed the whole way, unwavering, precise, patient. You smile, not because it's fast, but because it's faithful, and in its loyalty, we are given the gift of perspective. Because of light's fixed speed, we don't just see where things are, we see where they were. We look into the sky, and we look into the past. The moon 1 second ago, the sun 8 minutes, the nearest star for years, and the edge of the observable universe 13 billion years. This light connects us with what was, with the ghosts of ancient galaxies, with the echoes of creation itself. Without it, we would be blind, not just in space, but in time. And so, you lie back in your thoughts, realizing The speed of light doesn't just limit us, it enables us. It is the canvas, not the cage, a constant that gives structure to motion, form to experience, direction to memory. Because of this, constant reality has a tempo, not too slow, not too fast, but just steady enough for stories to unfold. And your story, your life, it too is shaped by this rhythm. Every breath, every thought, every blink of light you see filtered through that quiet pace. And maybe that's the softest truth of all. You are not separate from this law. You are part of it. You are a slow traveler in a universe of motion, bound not by speed but by story, one that unfolds moment by moment, photon by photon. And that is enough now. Let yourself float, truly float. No ship, no destination, just stillness. You're weightless but not lost, suspended in a web of light, faint, endless and calm. The stars glow around you like embers in an infinite hearth. They don't flicker, they don't hurry. They shine with the slow confidence of something ancient, and unbothered light passes you by, quiet, steady, gentle. It doesn't notice you, but it doesn't need to. It simply moves, always unstoppably without asking permission. And you, for this moment, understand that you don't need to chase it. You don't need to catch it. You are already within its rhythm. The universe does not demand speed. It offers time. Time to grow, to think, to rest. You breathe, slower now. Inhale, hold, exhale. There's nothing urgent out there, not in this moment. The galaxies will continue spinning. The light will keep traveling, and you are allowed to drift. Let the quiet take over now. No more questions, no more chasing. Just light, just space, just rest. And as you close your eyes, let the speed of light hold you, not as a barrier, but as a lullaby. The universe is still moving, but you don't have to. Not tonight.